Okay, class, you're watching Forces in Motion, Lesson 2.1. What is a force and how do I calculate it? Well, to discuss what a force is simply a push or a pull. I see a bunch of different pushes here. The pitcher that's throwing the baseball. I see the balloon here that is the water is pushing outward as a result. I see the person on the wakeboard. He's shooting up in the air. He's being pulled, and the guy pushing is the jogger as well. He's pushing the ground, and as a result, he's being propelled forward. And every force that we talk about, it has two things. It will always have these two. The first is the strength of it, which we call the magnitude. It's M-A-G-N-I-T-U-D-E, magnitude, which means how strong the force is, and our unit that we use is newtons. Okay, and then not only is the force a strength, but also a direction. That force needs to be going somewhere, so north, south, east, west, up, down, all those different places. And you need to have both of those to discuss force. And so just like any other measurement, a force has a unit of measurement, and we always, if you remember weight was a measurement of the force of gravity, and we measured that in newtons. This is also measured in newtons. And we use a big capital N for that. And the formula that we use for it is force equals mass times acceleration, where F equals force, M equals mass, and A equals acceleration. And so when I multiply the mass by its acceleration, how fast it is increasing speed, I can then calculate how much force was applied to it to create. So let's take a look at this one problem here. We have this car here that is 2,000 kilograms, and we have this person, sorry for the stick figure, is pushing it at a at an accelerated rate. It is being pushed at 0.5 meters per second square, which means meters per second every second. So it's increasing in speed half a meter per second. And so what I do is I just simply multiply those. So I would do force equals, and my mass is 2,000, times 0.5, which is the same as dividing by 2. So we end up with force equaling 1,000 newtons of force. Okay? And not just pushing things would be acceptable, but also, I mean, any type of force can affect an object in many ways by simply, pushing, as we saw, pulling, changing speed, direction is changed as well, and also its shape can be changed. So if you're playing with Play-Doh or something like that, its force applied can change its shape. And so our unit for force is measured in newtons. And then we have mass, the amount of matter in an object. This is also known as inertia. And that unit is in grams. And then we also have acceleration, which is the rate of increase in speed of an object. So if you're running faster, or it's also running slower, we call things that slow down deceleration, whereas things that speed up, that is acceleration. And the unit will be given. It'll be meters per second, or miles per hour every hour, and all those different things. And in essence, it's the length of unit, or the length unit. So if it's meters, miles, inches per unit of time for every unit of time. This shows the increase or decrease. Every second it's increasing at this speed. Speed up or down per unit of time. So if I look at this problem in your notes, Fred was running at a rate of 4 meters per second. He has a mass of 50 grams. What I do is I just simply multiply the 50 grams times 2 meters per second, which gives me the 100 newtons of force. That's how fast he is. That's the force he's applying to go that accelerated rate with his mass. So let's take a look at these. We have a car weighing 1,000 kilograms. This is our first example, traveling at a rate of 20 meters per second. How many newtons of force is the car was the car traveling with? So we do this problem. I got F equals M times A. I apply the variables value. So we have a mass of 1,000 grams times 20 meters per second squared. And I multiply those, so I end up with a force equaling 1,000 times 20. That's going to give me 20,000 newtons of force. So let's take a look at this next one here. A ship is accelerating at a rate of 3 meters per second squared. It weighs 3,500 kilograms. What is the amount of force for which the ship is traveling? So we put our formula again. Force equals mass times acceleration. And so we need to figure out what is our mass. So that would be the 3,500 kilograms. Okay, accelerating at a rate of 3 meters per second. So I multiply that times 3. And so with that, I would do 3,500 times 3. And so I do 3,500 times 3. And that gives me 10,500 newtons of force. So I'd write force equals 10,500 newtons of force. And so that's going to conclude our lesson on what is a force and how do I calculate it. Remember, your formula is force equals mass times acceleration. Now, make sure your notes are copied and that those are completed, and then you'll be spending your activity tomorrow if this is homework, or you may work on this next. You'll be doing the force blitz. So look at your directions on your Moodle page, and then you'll work on that to show me your knowledge of forces.